All right, let's jump into our last conic of this chapter, and that is the parabola. So we are just going to go over a few terms that are often used with regards to the parabola. So here's a paragraph. Let's fill in the blanks. A parabola is the set of all points x and y in a plane that are blank from a fixed line. The word here is going to be equidistant. From a fixed line and a fixed point. Our fixed line is going to be called the directrix, and our fixed point is going to be called the focus. Okay, and parabolas will only have one focus, whereas with ellipses and hyperbolas, you always graft two. The midpoint of the segment from the focus perpendicular to the directrix is called the vertex. And this is going to be the main point when it comes to parabola. So you know how everything was graphed from the center when it came for circles, ellipses, and hyperbolas? Well, our point of reference that we will always start from is the vertex. The line that passes through the vertex and the focus is called the axis of symmetry. So down below, you are going to notice that we as well are going to be dealing with orientation, okay? The parabola can either be facing upwards, downwards, left, or right. So vertical orientation, even though that they're only showing you a picture of a parabola facing upward, please know that they also are expecting you to infer that a downward facing parabola is also one with a vertical axis of symmetry. The parabola with a horizontal axis can either point to the right or to the left. So even though this was just pointing to the right, please know that left-facing parabolas are also considered horizontal. So we will have vertical axes or horizontal axes, and what they're talking about specifically is the axis of symmetry. Notice here, this here, I'm going to put a little red dot here. That's your focus, and then that's your vertex. So the line that goes through the focus and the vertex is known as the axis of symmetry. So if our axis of symmetry is vertical, we know that the orientation is going to be up or down. If your axis of symmetry is horizontal, why? It's going through the vertex and the focus. We know that our parabola is going to be full to the right facing or left facing. So let's actually do an example so that it helps you understand. But you'll notice that there is a chart, and like the other conics, I asked you guys to kind of ignore the noise in this chart. So truly, you do not need to be memorizing this. That's just too much, okay? What I need you to focus on is the following. Focus on the orientation. The orientation is whether it opens up, down, left, or right. Okay, so this is your orientation. And I want you to be able to look at the equation, the standard equation, and determine whether it is a horizontal or vertical parabola. And here's how you will do that, okay? You are going to focus your attention on this coefficient. So I'm going to circle this right here. This coefficient that is in front of the non-squared term. So I want you to notice here with parabolas, let me make a note here. They only have one squared term, okay? So only one term is being squared, whereas with ellipses and hyperbolas, you had two squared terms, an x and a y squared term. So notice here I'm going to highlight, nope, that's covering up, but I'll put an arrow. That 2 right here, okay, that's a squared term. That's a squared term. There's no other squared term. So that means this is a parabola. So when I ask you to focus on the coefficient of the non-squared term, I'm asking you to focus on the one that does not have a square. So this term and this term determine orientation, because if you look to its right, notice that that's pointing to a y. Now the y-axis points either up or down, as you see down here below. So if it's up, your p-value is going to be positive. It's down, your p-value is going to be negative. Now, look at the other equation. Right here, if your 4p is in front of the x, or the coefficient is in front of the x, that means it's going to be right or left. If your p-value is positive, then it points to the right. If your p-value is negative, then it points to the left. Okay, so let's practice what we're doing here, what we just finished discussing. So I'm not going to do example 1. I'm going to leave that for you guys to practice on your own. I'm going to actually do example 2 and number 3 and number 4. So I'm actually skipping number 1 and number 2. You can work at those on your own. And here's number 3 and number 4. So let us start first by starting out with orientation. So orientation is down here, and I know this is not a very good listing order, and it will be listed much better on your test. But here's number 1. Step 1 is orientation. Orientation is determined by looking at the number in front of the non-squared term and seeing what it's next to. Now notice the 12 is next to the y. Because it's next to the y, I know it's going to be an up-down situation, okay? But is it going to be up or down? Well, since the 12 is positive, that means I'm going to focus on it being up. Okay, so what does that mean? That means my final answer, my graph is going to be an upward facing parabola. Okay, where I have a vertex right here in the center. Okay, that's what my final graph is going to look like. Next, step number 2. Step number 2, I'm going to put it over here next to this letter P. Step number 2 is to find P. Okay, so I'm going to put the word find here to remind you. That's your new step. How are you going to do that? Well, you're going to take this equation, 4P, and set it equal to the coefficient you circled, 12. As you recall, if I backtrack, 4p is the one in front of the y minus k. So right here is my 4p, and I'm setting it equal to whatever number is in front of my non-squared term. So in this case, my 4p is the 12. So 4p equals 12, and then I need you to solve this equation. Now, how do I solve for p? Well, that means it's going to require me to divide this side by 4 and this side by 4. So P is 3. Okay, and that makes sense because I'm supposed to get a positive number because I said it was going to be upward facing, right? Okay, third step. I want you to go graph your vertex. So my vertex is always going to be what's opposite in my parentheses. So H is the X component. So opposite X is going to be a positive 2. And K is my Y component. Opposite of negative 1 is positive 1. So let's go over here and go to 2, 1. And here is my vertex. I'm going to label that V for vertex. I'm going to put it right here like that. V for vertex, okay? Next, step number 4. Let's put it right here. Focus. Step number 4 is going to be the following. You are going to, in order to be able to graph focus, I need you to start on the vertex. I'm going to use V for vertex, okay? And I want you to orient, in other words, use the orientation, orient by however much is your p-value worth. Now, you guys just told me that p-value was equal to 3, Okay, there was your p-value. And my orientation is circled down below as up. So I'm going to start on my vertex, and I need to go up 3. So I'm combining steps number 1 and 2. Okay, so up 3. 1, 2, 3 from the vertex, and I'm going to put a dot. Okay, and that is my focus. Step number 5 says draw a dashed line through the vertex and the focus. Oh, I forgot to put my coordinates of my focus. That was 2, 1, 2, 3, 4. Let's go back here and do that first. 2, 4. Okay, for axis of symmetry, I want you to draw dashed line through your V and your F, your vertex and your focus, okay? So I'm going to draw that dashed line through my vertex and my focus. Let's see if I can pull that off here. Draw as long as you can. And what I'm going to do here is make sure that I make it a dashed line. So let me do that really quickly here with my eraser. So I'm going to make sure. So when you draw your axis of symmetry, please know that this has to be a dashed line, okay? Now, this purple dashed line is vertically going through my x-axis. At what point? It's going through the 2. So the equation for axis of symmetry, I'm actually going to write in purple here, is x equals to 2. Okay? X equals 2. Because it goes through the x-axis at positive 2. Now, step number 6 is directrix. Let's use a different color here to make it pop out. Let us use blue, okay? So step number 6 for directrix. How do we do that? All right, well, step number 6 for directrix says that you have to draw a perpendicular line, okay? Perpendicular line to your AOS, axis of symmetry. So if I just drew a vertical line for axis of symmetry, that means I'm going to draw a horizontal line, okay? Now, where do I draw this horizontal line? Well, because I'm running out of space, I'm going to kind of write it down here. So when you draw the perpendicular line to AOS, I want you to take the opposite orientation, and then apply your p-value. Okay. So you just told me in order to find the focus that you did up 3. In other words, steps 1 and 2, you said up 3. What is the opposite of up 3? Well, it's down 3. So I'm going to go down 3, 1, 2, 3. And at that spot that I stop, I am going to draw a dashed vertical line because I went down 3. 1, 2, 3. And then I drew my line, okay? And so this here is your directrix, okay? And since my directrix is going through the y-axis, okay, I am going to write y equals. So I'm going to start y equals, let me put it in blue again, y, I ran out of space, so I'm going to put y equals -2. So notice that for steps number 5 and 6, one is an x equals equation and the other one is a y equals equation, okay? They always have to have opposite letters. The numbers have nothing to do with it. As long as the variables are opposite, you know you wrote them as perpendicular. Now, here's the last step, okay? Last step is number 7 step. So let's make number 7 step in green. So number 7 step is determining how wide your parabola is going to be. Okay, what is the wideness of your parabola? Is it very narrow or is it very wide? Well, you are going to use the formula 2 times p. Well, in this case, our p-value was a 3. So, whoops. Let me put that plus minus again. So 2 times my p-value in this case is 3. So my answers become plus minus 6. So how does that help me? Well, I remember telling myself at the beginning, the example, that my graph was going to be upward facing. Okay? So since it's upward facing, I know that it has to go through the vertex and go up. But the problem is, I don't know how wide I'm supposed to graph this vertex. I mean, not this vertex, this parabola, right? So the question is, how wide do I draw it? So you're going to use the distance of 6, and you have to count from the focus, okay? So this will always be counted from the focus. So from my focus, I'm going to count 6. 1, 2, 3, 4, 5, 6. So I'm going to put a point right there. And I'm going to do the other direction. 1, 2, 3, 4, 5, 6. And I'm going to put the second point right there. And that tells me how wide I'm going to draw it. So from the vertex, I am going to curve upward. Let me try that again. I'm going to curve upward, cross through the green, and I will do it the other direction as well. And there's your parabola, concave up. Notice that the distance from vertex to focus and vertex to directrix are equidistant, just like the notes that we had earlier. Okay? So let's do example 4 and go a little faster. Okay, so the first thing in example 4, we are going to what? Our first step is to start with the orientation. Step number 1, orientation. So I go upstairs, I look at my coefficient, and look at what's in front. Okay, the non-squared coefficient. So that's a 10 next to an x. So I know right, left is what is happening. Okay, I know I have to choose right, left because it's an x it's next to. Now I have to decide, is my x value, is my coefficient positive or negative? Since it's a positive 10, you are going to have a parabola that's facing to the right. So I'm going to put a picture here, a right-facing parabola, to remind me, hey, when your final answer is being given, this is what you're looking for, a right-facing parabola. We're going to do the same equation, 4 times p, and set it equal to that number in front, the one you circled, and divide both sides by 4. So you are going to get 10/4, or if you reduced it, 5/2. But we know that we're going to use decimal values. So you can either give me 5/2 or 2.5 for your p-value. Okay. The vertex. The vertex is the opposite value here next to the y-squared. Well, there's no number, so I'm going to use 0. And the opposite value for this one right here, well, x is not adding or subtracting next to anything, so that's going to also be 0. So x comma y is 0, 0. Okay. So I'm going to come over here and put my point at 0, 0. Okay, that's my vertex. So I'm going to put V for vertex. I'm going to combine steps number 1 and step number 2, P, and do them together. Write 2.5. So 1, 2.5 is my focus. Okay, write 2.5 is my focus. Then I draw my dashed line through the vertex and the focus. So actually I'm going to make that a little bit thicker so that we can see it, because that was hard to see. So through the vertex and the focus. And I will put put arrows at the end. And I will also make sure it's dashed line. So let me erase these a little bit. And you can do the same thing with your pencil. Okay. And now that I have that, I need to do the opposite of what I just did to get the directrix. Well, I just went right 2.5. So from the vertex, I'm going to go left 2.5. And I'm going to put it right here. Okay. Left 2.5. And this is the directrix. Okay. Let's put this arrow and this arrow. And I guess we can label the focus and all that because I haven't done that. So the focus went to the right 2.5 comma 0. So 2.5 comma 0. The directrix, let's do axis of symmetry first because that's what I did first. Axis of symmetry is the line that goes through those two. It is going through the y-axis at 0. So axis of symmetry is y equals 0. So directrix has to be x equals because I just did y equals. Directrix, it's going through the negative 2.5 line. So that vertical line is going through negative 2.5. Now we need to do the width. The width is 2p. So 2 times p. In this case, ours is 2 times 2.5. That's going to give me a 5. So I need to count by 5. Now, in what direction am I going to count by 5? Well, I'm trying to determine how wide my graph is. Remember that, right? So if that's my vertex, I know that I'm doing this, but I don't know how wide is my parabola going to be, okay? How wide is it going to be? So I need to count from my focus. My focus, put your pencil on F, and I need to go up and down 2.5. So I'm going to go up 2.5, and I'm going to put a dot right about there. I'm going to go down 2.5. I'm going to put a dot right about there. And then I am safe to draw. Wait a minute. Did I say it was upward facing? Did I mess up? Oh, no. Oh, my goodness gracious. I backtrack. I'm so sorry. Let's backtrack. I had to go right. No, not right. It was the Y. It was next to the Y axis. No, it's X. What am I doing? I am right. I'm looking at example number 3. Oh my goodness. So I'm going right 2.5. Okay. I am doing okay. Don't erase anything. We are okay. So we need to, I was looking at the example 3. I am so sorry. I got so confused. So we are doing just fine. So here we go. At the F for focus, we needed to go up and down 5. Okay, so here I'm going to go 1, 2, 3, 4, 5. And I'm going to put my dot right about, why is it not drawing? Right, 1, 2, 3, 4, 5, right about here. And I'm going to go down by 5. 1, 2, 3, 4, 5. And yes, we're okay. And from here, we are going to, from the vertex, draw our parabola facing to the right. That's coming out really ugly. Facing to the right. And the width helps us establish how far up and down we went. So notice that this right here, that distance will always be 2 times your P. Okay? Whereas up here, this time your distance was horizontal, and that was 2 times your P in number 3. Okay, so sorry about that hiccup. When I was starting to graph, I kept looking at example number 3, and then I got lost. So, too much information on this one page. last but not least, here we go. Here is this section, example number 5. So what's going to happen is that you are going to be given a general form of a conic that looks like something like this in the rectangle. You don't need to memorize this by any means, okay? I wrote it out because I specifically want you to make sure you understand that all I care about you finding is the A value and the C value. That's all I care about you finding. So notice that your A value is the coefficient of x squared, and your C value is the coefficient of your y squared. That's all I need you to look for in order to help you classify the conic, okay? This box that is highlighted in yellow will be provided to you on your test day, okay? So let's look at part A. Part A, you are going to look for your x squared term and your y squared term. So let's eyeball it there. And do you see your x squared term already? Hopefully you see it. There's your x squared term. And here is my y squared term. Well, let's identify capital A and capital C. Well, capital A is the coefficient of x squared. An invisible 1 is in front of it. Capital C is the coefficient of y squared. A positive 4 is in front of it. Once you have identified A and C, you're going to go to the box and check. Is A equals to C? Is 1 equals to 4? No, it's not. So circle, answer eliminated. Notice now, in the next 3 examples of conics, they have written AC, okay? So AC means take the 2 numbers you found and multiply them. So in this case, AC for me was 1 times 4, which is 4. So now you're going to ask yourself, well, is 1 times 4 equals to 0? No, it's not. So that's not going to work. Is the 1 times 4 greater than 0? Well, 4 is definitely greater than 0. Yes, it is. So our answer is an ellipse. Okay. Let's do B. Identify A and C. A and C. So go ahead and take a second and do that. All right, so you should have put A to be 1 and C to be 1. This is your A term. This is your C term. Okay, the number in front of x squared and y squared. Now, you go again through the table. So I'm going to erase here the table. And we start. Is A equals to C? Well, in this case, yes, A was equal to C. They both are 1s. So you are just going to tell me that this is, whoa, that's funky, that this is a parabola. Go ahead and pause and do C and D. Okay, thanks for pausing. So let's do this one. All right, so the A value here, in this case, you should have written is a negative 2. Watch the order because A is next to x squared. And my C value was a 4. So I know it's not A equals C. I need to multiply it. Well, AC in this problem is going to be a negative 8. Is negative 8 equals to 0? Nope. Is negative 8 greater than 0? Nope. Is negative 8 less than 0? Yes, it is less than 0. So hyperbola will be this one. And the last problem of our notes. Again, identify your A and your C. So let's do that. A in this problem is the coefficient of x squared. So I have 2y squared, 2x, 2y plus 1. There isn't an x squared term. So it's going to be 0. My C value is the number in front of y squared, 2. So again, one more time. Is A equals to 0? In this case, nope, the numbers are not the same. So eliminate. Then AC, 0 times 2 is just a 0. So is AC equal to 0? Yes, it is. AC is equal to 0 on this one. So, oh my goodness. See, I did make a mistake. Oh my gosh, students. Well, I hope you were paying attention. Were you totally saying, Hanlon, you've got this wrong? Yes, I had it wrong. I'm very tired, and this is why you do not record at, what time is it? 9 o'clock at night, especially after a long day. So, if you caught my mistake and ignored me, you should have. This is a circle. Whoa. So, ellipse, circle, hyperbola, parabola should have been your answers. Thank you for hanging in there. That is our lesson on parabolas. Let me know if you have any questions.